In this video, I give access to GPT-4-vision to autonomously play chess on chess.com. It has access to a keyboard, a browser, and a screen, and it takes a screenshot and it decides what's the next best move, and then it outputs it on the keyboard to then play that move. It plays a computer and then later a human. There's a long history of AI playing chess. There was Deep Blue by IBM, and there was AlphaZero by DeepMind, which used reinforcement learning. And more recently, people have experimented with how large language models play chess by, I think, reading it in some kind of language, the game board into an LLM. I thought it would be interesting to see how a visual language model, such as GPT-4-vision, does at playing chess. This requires it to do a few things well. And in order just to make a valid move, it has to read the board and decide where the pieces are, and decide where each piece can move to. And then it has to actually know that on the grid, like A1, and decide where it's going. And then it has to also output that in like JSON is how I set it up, to actually be like validly fired by software. And so there's a lot of things going on just for one valid move to happen by a visual language model. So I thought it was interesting to see how it did autonomously playing. And it makes many valid moves, but it often makes invalid moves. And I think it's interesting just to see how it does like play through. So I have each iteration here that you can see how it improves, and then finally it plays a real person. I also included how Claude did in one of the iterations. So real quick, let's look at the repository that makes this possible. This project's possible because of Multimodal Gamer, which is a framework that enables multimodal models, such as GPT-4-vision, to play games on computers. It takes a screenshot and then it lets the model output keyboard and mouse commands to play the game. Now let's look at the iterations of this project on chess.com. Okay, first version is working. Start it up. Okay, so I clicked into the input. So GPT-4-vision is going to type into this input the moves. It's going to take a screenshot first. Okay, so it decided its move. Took a screenshot. Types its move. Takes a screenshot. Should be trying to figure out what it's going to do next. G1, F3. Invalid move. Okay, so it failed to decide a valid move on that one. So it needs some work. Now it's entering in more moves because it thought it was successful. Now it's just going to keep on typing and failing. So I'm going to go improve it, see if we can make it not do invalid moves. I've improved the prompt so that some of the common invalid moves that GPT-4-vision was making, it knows to avoid. And I've also improved the code so that if it fails, it can try again. Now let's see how it does. I'll start it up. Okay, so I'm entering, I just need to enter this text input at the bottom, and now it can autonomously just go. So let's see how it does at playing chess now. Okay, so E2, E4. Okay, took a screenshot. I didn't catch. Okay. Okay, nice. Yeah, I think that was a decent move. I'm not very good at chess, so I'm not a good judge of how it's doing. Okay, cool. I didn't even know that move existed till recently. I think it's making less invalid moves on this iteration, but okay. Okay. Nice. Without being great at chess, I think it appears to me that it's doing well. But this is playing on chess.com. It's playing computer on medium difficulty. Okay, that was an invalid move. So it should try again now. The prompt now says if the piece doesn't move, then you made an invalid move. And try a different move. Another invalid move. So this is the biggest challenge I'm seeing right now is sometimes it tries to move a piece that's not even on the initial position, or it tries to go through pieces. Like what's the C4? C4 to D5. So it's trying to move a piece that's not there. Okay. GPT-4-vision is having a little latency on this call. C3 to E5. So it just tried to move one letter column over too far. That is not a valid move. C3 to E5, and it didn't listen to my prompt instructions to never do the same move twice. All right, so definitely room for improvement. We'll see if there's any prompting that can fix these issues, but it's possible these are just inherent with GPT-4 and that it wasn't trained on chess, or it could be the spatial awareness. It could be a lot of issues. So anyway, we'll see if I can build a new iteration. So I've made changes to the prompt, such as moving the prompt from using universal chess notation to using algebraic notation, and I've given it more information, less information, but GPT-4-vision it can't help but eventually make incorrect, invalid moves. So I thought I should try Claude. So I have Claude running here. So -m Claude at the end of my terminal there, you can see it's running. So, okay, let's see how Claude does. Took a screenshot. So Claude should be processing that screenshot via its API. Should come back with a move here. Okay, so it decided G1 to F3, so that's correct. I'll try to read what its thoughts are on these moves. Next move should be coming here any second. The latency for Claude's API and GPT-4. Black has responded. Okay, I didn't catch that for full thought. But latency on GPT-4-vision API and Claude is about the same. Did it make an error? I think it must have made an error. F1 to C. Yeah, it didn't understand in that last move that there was a pawn in front of, and it made another invalid move. So E1 to G1. Oh, it tried to swap. I don't know what it was trying to do there with E1 and G1, but I'm not a very good chess player, so that might be a move I'm not aware of. Another valid move. So Claude is struggling. Let's see, we'll give it one more shot to make the correct move. E4, E5. Why? So it just hallucinated a piece there. So yeah, Claude is struggling. Let's see how GPT-4-vision does playing with a real player online at chess.com. Even though there are issues with invalid moves, it can correct itself in the second or third move. So I have a video of it playing through at 4 times speed, and you'll see in the first half it does take some of the player's pieces, but it definitely loses more than it takes, and the other player was much better. But it's interesting to see how it does. In the second half, I realized that there was an issue going on where it just got into a loop and kept on making the wrong move. So I restarted it to see if I could to get it working again, but didn't end up recovering. The match ended up timing out. I think that if given enough time, like, you could actually get GPT-4-vision to complete games, but it would be pretty hard and it would cost an arm and a leg on the OpenAI API. So I didn't go through the whole process to try to get it to finish a game. But here it is playing at 4 times speed. So we saw that both GPT-4-vision and Claude struggled to make valid moves, especially once they were like 6 or 7 moves into the game. Let's look at the instructions that each were working with. This is the prompt that I basically send along with the screenshot to the APIs, and these are the instructions that they follow when they are playing chess. So pretty simple. I just say, you're a master at chess. Your objective is to play the strongest move at each turn. And I start providing additional context so that the model can basically create a valid output. So, you're interpreting a chessboard and use UCI, which is Universal Chess Notation. I explain the different moves, but I don't know if this is really needed. It might help a little bit, but I experimented with few different prompts, and being more giving more explanation to chess seemed to help. But I don't know. I think I could have experimented with prompts more, but this is the one that seemed to perform the best. I mentioned the special moves, and then some other important notes. So it's just, your chess pieces are the white ones and your opponents are the black pieces. And then also just some context about if the chessboard doesn't update, then the last move was invalid. Never try the same move again. And just kind of making it think, like, you can't go through pieces. So if there's a pawn in the way, you shouldn't try to go through. And just kind of information about the grid before moving. check the original grid square before trying to move it in UCI. And then this is the output right here, this kind of code looking thing. It's JSON. It's like a way for me to interpret the response from the model and load it in the code essentially. So I require it to have a thought, an action, and a reason. And so the action is the move. And so this is a little bit about the prompt. But like I said, I experimented with a lot of different prompts. I tried a simpler one up here, but nothing seemed to really get these models, these vision models, past them making invalid moves.